All right, welcome back. Let's keep going with Chapter 11. This is Section 3, talking about finding the areas of the sectors and arc lengths in a circle. So our I will today will be I will find the areas of sectors and segments. So right now, if you have sticky notes that you either picked up in class or of your own, you may want to pull those out. Otherwise, you might want to do a foldable or just write them in your notes. That's totally up to you. Okay, so I'm going to start with defining the area of a sector. A sector is basically just a portion of the circle. It's kind of like in a pizza. It's a slice of pizza. So we're going to find a portion of the full area of the circle. Okay, so that's what we're finding. So we're going to use pi r squared. Okay, and we're going to multiply it by just the portion that we need. All right, so we're going to use this angle. Remember that a full circle is how many degrees? 360, correct. And 360 fills up the whole circle. It's not just 360 around the outside. It's 360 inside the entire circle, okay, because it goes around like this. And that's why this whole section takes up a portion of 360 degrees. So our formula is going to be area equals pi r squared, which is the full area of the circle, times the portion we need. The m, or the degrees of the angle they give you, over 360. Okay? Then when you're finding the area of a segment, now, I will say this is where it gets a little confusing trying to remember which one is segment, which one's a sector. Well, let me give you maybe a little hint. Notice that in a segment, it is bound by a chord or a segment, where it has two definite endpoints. So here, this portion is bound by the arc of the circle and the chord, or a segment, as opposed to the sector, which is bound by two radii and the arc of the arc of the circle, pardon me. Okay, so here, the way that we're going to find this is we're going to find the full area of the sector, okay? Then we're going to subtract out this triangle-looking one. Let me zoom in so you can see it a little bit better here, okay? We're going to subtract out the area of this triangle. Usually it's going to be a right triangle, but you can do it with different ones. And that's going to leave this little white section right here, which I have colored in over here, which is going to be our area of a segment, okay? So we take the formula for the sector, pi r squared times m over 360, and subtract out the triangle, 1/2 base times height. Okay? We'll practice this in just a second. And the last thing that you need to learn in this section is how to find the arc length of a circle. Now, we've been talking about the area of a sector and area of a segment, all having to do with the full area of a circle. Well, the arc length is just this outside piece. It could be anywhere on the circle, okay? But it's using not the area, but the what? Right, the circumference, okay? So now instead of a portion of the area, we want just a portion of the circumference. So we're going to do the 2 pi r, that's the circumference, and multiply that by the portion that we need, which is the angle, over 360, because that will give us just a piece of the circumference that we need. So 2 pi r times m over 360. Okay? All right. If you need to go back and write anything down or recopy, feel free to go back and do that now. But at this point, we're going to move over and do some examples. So I'm moving to the left side. I'm still going to use some stickies here. So the top, I'm going to start with an example of finding the area of a sector. So I've given you the full circle, and I've given you a colored in piece or portion of the circle where the angle in here is 40 degrees and I have a radius of 6 inches. Okay? So remember, when we're finding the area of a sector, we find the full area and multiply it by just the portion of the full thing that we need. So 40 degrees out of the 360. Pi r squared times m over 360. I also want to point out, notice how it is named. Area of sector DEF. Okay, it's named by the points that bind it. Okay? All right, so when we fill in our formula, we get pi times 6 squared, that was our radius, times the 40 degrees that they gave us over 360. I'd like you to get in the habit of just reducing this fraction so that you can start doing a little bit more mental math, possibly, in order to get your exact answer. Notice 36 divided by 9 is 4, so 4 pi centimeters squared is our exact answer. Or if you multiply it out, you get about 12.57 centimeters squared for the area of your sector. Okay? Let's move over to the area of a segment now. And of course, if you need to pause me and go ahead and copy this down, as always, feel free to do so and then keep going. But finding the area of a segment, remember that's just this little piece bound by the arc of the circle and the chord, or a segment. So we are going to find the full sector, hence this part of the formula, subtract out this triangle, which is this part of the formula, and find segment ACB. I want you to look at this. It's named just like the sector was, with the 3 points right here, including the center. But notice that's why you have to say either sector ACB or segment ACB. That part of it is very important, unlike, for instance, triangle. Okay? So let's see. When we fill it in, pi r squared, the radius was 3 inches. Also, I want to show you, this is a 90-degree triangle. That means, and this is a piece that's going straight from the center to the outside, so this too is a radius, which makes it 3 inches as well. So we get pi 3 squared times the 90 degrees over 360, because the 90 degrees is where the segment is, minus 1/2 base times height of this triangle. And the base and the height are the same thing since they are both radii. So 1/2, 3 times 3. When I reduce it, I can end up with 9 pi over 4 minus 4.5, or one more step is 2.25 pi minus 4.5, or going ahead and multiplying it all out gives you 2.57 inches squared. Okay? So as you noticed, this is a lot of just memorizing formulas, which for my class, this is why, guys, I wanted you to start memorizing these little formulas, because if you notice, all the formulas you start using are little ones all put together. This is the area of a sector minus the area of a triangle. Okay? Some are new, but if you'll memorize the little ones, then remembering the big ones isn't as hard. All right, and then we do arc length. Okay? Remember, this is just a portion of the circumference of the circle, so we're going to use the 2 pi r instead of pi r squared. 2 pi r, and they've given us a 45 degrees. Now, that's actually this angle in here. That's 45 degrees right there. So we're going to use 45 over 360, and we're going to find length of arc xy. This is how you write arc of xy. So 2 pi times the radius, which was 5. Okay, even though that's way down here, remember the radius is the same no matter where it is in the circle. So 2 pi times 5. Times 45 over 360, that was the angle they gave me over 360. I reduced my fraction to 1/8, and I end up with 10 pi over 8, which reduces to 5 pi over 4 feet. Notice it's not feet squared, because we're only looking for a length, a distance around the circle, not the area. And if I need it in a decimal, it's about 3.93 feet is the length of your arc. All right, that has finished up the section of 11.3. Okay, if you need to go back and finish copying anything down, feel free to do that, of course. And as always, if you're a little confused still, please go back and rewatch the video, one more time. It's only a few minutes long. That way, when you come tomorrow, you can come with some really good questions. That way, we can solidify your knowledge, and when you do your application, you'll know exactly what you're doing. All right, you guys have a wonderful day. We can't wait to see you in class tomorrow. And as always, if you have any questions at all, please feel free to email me or Miss Scott. See you then.